Alright, you guys, welcome back to geometry. We are on lesson 91, Introduction to Trigonometric Identities. My name is Miss Elsner and I'm coming to you from the Maricopa campus. Today's objective, students will be able to analyze trigonometry by discovering trigonometric identities. Sorry about that, I'm getting a little bit tongue-tied. All right, trigonometric identities. The most commonly used trigonometric identities are below. Would you please get these into your notes? These are important. We will be using these throughout this lesson today. So the first identity that they're talking about here is we've got tan theta is equal to sine theta over cosine theta. We also have sine squared of x plus cosine squared of x is equal to 1. Okay, if you need more time, go ahead and pause the video. But we're going to move on. In that first one, or in this first slide, all we're doing is proving why this identity works. Okay, so what they're doing is they gave us a triangle, a right triangle here, and we are going to take a look at this proof. Okay, remember that we have SOHCAHTOA, in case you forgot over break, and we're going to be using that to substitute in for the sine and the cosine. Okay, so we've got our angle x right here. When we're talking about sine, we're talking about opposite over hypotenuse. So the opposite side is the A. The hypotenuse side is going to be the C. And you can see that we have this right here with AC squared. Okay, the cosine is going to be the adjacent side, which is the B. And over the hypotenuse, which is going to be our C, and that will leave us with our B over C squared. Okay, so if we square both of those, we'll get A squared over C squared plus B squared over C squared is equal to 1, as you can see on our next line. We want to get rid of those C's that are in the denominator. So in order to get rid of those C's that are in the denominator, we can multiply everything by a C squared. Our basic algebra. These C's are going to cancel out, and it transfers the C squared to the other side. And hopefully this equation looks familiar to you. This is our Pythagorean theorem. And it's showing that this identity is demonstrating the Pythagorean theorem, and we already know that that's true. Okay, so that's how that works. All right, in our first example problem here, it says that we need to find sine theta if cosine theta is equal to 0.5. All right, so let's go ahead and write down our identity. We've got sine squared theta plus cosine squared theta is equal to 1. Okay, next we're going to do our substitution. We've got sine squared theta, and we have our cosine is given to us as 0.5, and we need to square that. Okay, if we go ahead and do our math and square this, oopsie, we have 0.25. We want to get that 0.25 to the other side, so we need to subtract. Okay, so I'm going to subtract from both sides, and I'll get sine squared theta, and then on this side I have 0.75. Now in order to get rid of our square, obviously we're going to have to take the square root of each side, and I'm going to grab my calculator here and punch this in. I've got, let's see, 0.75. If I take the square root of that, you're going to get 0.866025. It's going to keep on going. But let's go ahead and simplify that. And to 0.87 will approximate and that's going to give us our sine of theta. Okay. Moving on, we have express tan theta using only sine theta. Okay. Sounds kind of complicated, but it's actually not that bad. So we're going to write that same identity that we used in the last one. So we've got sine squared theta plus cosine squared theta is equal to 1. All right, so we want to get the cosine all by itself. So in order to do that, we are going to subtract sine from both sides. And when you do that, you will get cosine squared theta and 1 minus sine squared theta. Okay. Next, what we need to do is we need to get rid of that square root sign. So in order to get rid, or not square root sign, we need to get rid of the square. So in order to get rid of the square, we're going to take the square root of both sides, and that will leave us with cosine theta is equal to 1 over sine squared theta. Okay, it feels like I should be done with this one, but I'm not. I'm running out of room. So hopefully you have this part written down, because I'm going to go ahead and flip my screen and clear this out. Okay, so if you don't have it, make sure that you pause it and get that written down. Next step, what we need to do is use the tangent identity. And we're going to say tan theta is equal to sine theta over cosine theta. Okay, all you're going to do is substitute in the cosine that we found in the first step. Okay, so we've got tan theta is equal to sine theta, and the answer that we got before in my slide that I deleted is going to be 1 minus sine squared theta. So we just substituted in for that cosine so that we're expressing tangent only using sine. We got rid of the cosine. All right. Next up, part B says express tan using only express tan of theta using only cosine theta. Okay, so what we're going to do is we know that sine theta here. We know that sine theta is going to be equal to 1 minus cosine squared theta. And the reason why that works, remember, is because all we're going to do is we're going to take that original equation. I feel like I'm kind of skipping here. If we do sine squared theta plus cosine squared theta is equal to 1. What we want to do is we want to subtract cosine from both sides. So we'll have 1 minus cosine squared theta. And on this side we have sine squared theta. And then you have to take the square root of both sides. And that's where we are getting this part from. Sorry, a little messy. Okay. The next part, we're going to just substitute this into the tangent identity, because now we want only cosine showing. We don't want any sine showing. So we are going to take our tan theta, and we have sine theta over cosine theta. That was in our identities that we wrote down in the beginning. And all we're going to do is substitute out that sine, and we are going to put in 1 minus cosine squared theta over cosine theta. So tangent theta is equal to the square roots of 1 minus cosine squared theta over cosine of theta. Okay. All right, we've got a table here that's outlining the relationship between the trigonometric functions. I highly suggest that you pause the video and let's get these written into your notes. So we have the function of sine theta. If we write that in terms of sine, it's going to be sine of theta. If we write it in terms of the cosine, it's going to be the square root of 1 minus cosine squared theta. And if we write it in terms of tangent, it's going to be tangent theta over the square root 1 plus tangent squared theta. Okay, the next row, if we have the function cosine of theta, that will be equal to, in terms of sine, we wrote it in terms of sine, it's going to be the square root of 1 minus sine squared of theta. If we write it in terms of cosine, cosine theta is going to be cosine theta. And if we write it in terms of tangent, it's going to be 1 over the square root of 1 plus tangent squared of theta. Okay, if our function is tan theta in terms of sine, we're going to say sine theta over the square root of 1 minus sine squared theta. In terms of cosine, it's going to be the square root of 1 minus cosine squared theta over cosine theta. And in terms of tangent, tangent theta is just going to be the tan of theta. All right, our last problem here that we have, example 3, we have an application problem and we're estimating distance. Okay, we've got Leo and Melody are standing on the streets near their school. They're shown in the diagram. Here is Leopold and here is Melody. Melody knows that she is 3 times as far from the school as Leopold. Okay, that would be our hypotenuse. What is the approximate ratio of Melody's distance from Leopold to Melody's distance from the school? All right, so to get this problem started, we're going to figure out, let's see, if Melody is 3 times as far from the school as Leo is, this is saying that the ratio of, we've got our opposite leg. So my opposite leg would be here. He's 1 times as far. And my hypotenuse would be 3. So that would be 3 times as far. So it looks like we have opposite over hypotenuse. That would give us sine theta is equal to 1/3. Because from this angle here, we've got opposite over adjacent. Opposite over hypotenuse. All right, but the problem is asking us for the ratio of the adjacent leg to the hypotenuse, and that is going to be a cosine function. So we can use the identity to solve for cosine. Okay, so let's use our identity that we have been working with for this entire lesson. We have sine squared of x plus cosine squared of x is equal to 1. Okay, we know that the sine is equal to 1/3. Need to square that. And cosine squared of x, that's what we want to find. All right, if you square 1/3, we are going to get 1/9. So in order to get it on the other side, you are going to subtract 1/9 from both sides, and you will get 8/9 on this side. Okay, my cosine squared of x is just going to drop right down, and what we need to do is take the square root of both sides in order to get rid of the square. Okay, so I can see that my cosine of x, my cosine of, actually in the problem it is listed as theta. So I'll just put it as theta because here it's a theta. That really doesn't matter, but if I go ahead and take the square root of 8, my square root of 8 is going to be 2. times the square root of 2, and then the square root of 9 is 3. So my final answer is going to be 2 times the square root of 2 over 3 times as far as the distance from Melody to the school. All right. Okay, guys, that is the end of lesson 91. Good luck with your practice problems, and I will see you tomorrow for lesson 90.